Today we will demonstrate how to prepare both solid and liquid samples for analysis by NMR. It is very straightforward and both follow a similar procedure. We will start with the liquid because it is simpler and we will give a good understanding of the general method. The liquid we have chosen is 2-ethyl-aniline because it will give us a clear, simple spectrum and it is brightly colored. The first step in the preparation is to take a clean glass pasteur pipette and draw up a small amount of the liquid. Since the NMR tubes are very narrow and they need not be filled, the pipette should be only full to just above the tapered section as shown. Transfer this directly into the NMR tube. Next we'll add tetramethylsilane, or TMS, which yields one very large peak close to 0 ppm and acts as an internal standard. In this case, and with many cases, the TMS also acts as solvent and dilutes the analyte. With a new pasteur pipette, draw about the same amount of liquid as before and dispense this into the tube. The two liquids may not mix immediately, but before trying other solvents, simply place the cap on the vial and invert the solution several times to encourage mixing. As you can see, often the liquids will mix with the TMS after a few inversions. Now we will prepare a solid sample. The procedure for solids is slightly more complicated because the solid cannot be put directly into the NMR tube. Instead, we will first dissolve it in a test tube and then transfer it. For this, we have chosen 3,4-dimethylphenol because it too is colorful and it will give us an interesting spectrum. Take a clean spatula and measure a small amount of analyte and transfer this to the test tube. Very little is needed because the machine is very sensitive. Next, we add TMS to the test tube. In many cases, especially with nonpolar analytes, TMS will behave as a solvent as well as the internal standard. Draw a small amount as before and release it into the test tube with the solid. You will be able to see very quickly whether or not the solid is dissolving. In our case, the solid does not dissolve in the TMS. The solution is dependent on polarity, and since TMS is nonpolar and didn't dissolve our solid, we now need to try some polar solvents to see if we can improve the dissolution. Here we use chloroform D. The D here stands for deuterium, which is in the place of the hydrogen in regular chloroform. Deuterium is what is called an H2 nucleus because unlike hydrogen nuclei, which contain only a single proton, deuterium nuclei consist of one proton and one neutron and therefore have a different mass. Since the machine will be monitoring only H1 nuclei, it will not register our solvent and we will not have any peaks that are foreign to our compound. As you can see, the solid has begun to dissolve, but it may take a few minutes for it to dissolve fully. Stopper and shake the test tube, and we will put it aside for now and prepare for the next step. There cannot be any solid in the NMR tube, so we have to filter our solution. This is best done with a filter pipette, which can be easily set up by taking a very small cotton plug and pushing it to the end of the pipette with a wire. You want a very small piece of cotton because if it is too large, the solution will drain too slowly. When this is done, it can be placed directly into the top of the NMR tube and it's ready for use. Once we have the majority of the solid dissolved, we're ready to transfer it. Take another clean pipette, draw this liquid, which now has our solid dissolved in it, and transfer this directly into the filter pipette. Be sure to transfer as much of the liquid as possible to the filter and let it drain through. If the liquid is draining slowly, it can be forced through with a pipette bulb. Now we're going to put a cap on the tube, invert it several times, and we're ready for NMR. While preparing samples, it is good practice to label everything, and this is no exception. However, because NMR tubes are so narrow, we use a special type of label. These are applied like any other label, but must sit flush with the tube when you're finished. One easy way to do this is by placing the center of the label on the tube and folding each side around. Also ensure that the label sits fairly close to the top of the tube. Now we're ready to use the machine. Be sure to sign your name in the logbook before getting started. Open the cover and you will see some tubes and wires as well as a narrow hole. At the top right of the machine is a button labeled Eject. While this is held down, compressed air will force out whatever has been left in the machine. There should be a standard inside. Take this, slide the magnet off, and put the tube aside. Now take the magnet and slide it up the bottom of your sample tube. Take the gray measuring tool and slide this in the same way up the bottom of the tube. This will simultaneously push the magnet into the optimal position and allow you to check the level of the sample. If the liquid is not above the indented region, the amount is not sufficient to complete a run. Observe the black line on the magnet. This will allow you to see whether or not the sample is spinning once the tube is in the machine. The last step is to give the end of the tube a wipe with a Kim wipe to remove any dirt or oils. Now, hold down the eject button and position the tube in the hole. Release the button and let the tube drop in. Check that it is spinning smoothly and close the lid. Now, we move to the computer, which controls the machine. The program used for viewing and editing spectra, called NUTS, will open automatically when the computer starts up. Press OK to close the dialog box that appears, and a white screen will remain. You will then need to open the PNMR program. At the bottom of the screen, you will see a yellow icon with the letters AII. Click on this, and another window will open, this one with a grid and a list of parameters. This is the program that controls the NMR apparatus. If the machine has not been used recently, you will need to do a shim. This aligns the magnets in a way that creates a uniform field and must be done with a standard before running samples. Simply type SHIM and press enter. A dialog box will appear asking for a relaxation delay. If the standard in the machine is ethylbenzene, input 5, or for any other standard, input 2. Then press enter again. The shim will then run for several minutes, and you will know it is done when the box in the bottom left corner of the screen turns from green to gray. At this time, you may replace the standard with your sample and begin testing. To begin a run, type ZG, then press enter twice. You do not need to choose a new file location or rename the sample. After a couple of seconds, an FID spectrum will appear on screen. If it turns blue and then black, the receiver gain is low or just right. If it turns red and then black, as here, the gain is too high and must be lowered. This is done by typing in RG followed by a space and then the number you wish to set it to. Press enter to apply this, and the new number will appear among the parameters at the bottom of the screen. It will most likely take several tries to find the highest possible gain that still yields a blue FID. Then, run the spectrum again using the ZG command. Repeat this procedure until you have found the highest possible gain. All typing is visible in the bottom left of the window, and if you make a mistake, you can press the delete key to remove any unwanted digits. Once the gain is at the optimal value, switch to the Nuts window. The key combination A2 will bring up the most recently acquired spectrum. Scrolling with the mouse will increase or decrease the magnitude of the peaks. The key combination SZ will move the baseline so that the largest peak is at 0. Most often, this will be the TMS. But in the case that it is not, or the SZ function doesn't work, a field offset is required. Double-click and the cursor will become a zoom tool. Now, click and drag the mouse so that the TMS peak is highlighted. Right-click and the program will zoom in on that peak. Press Enter to exit the zoom function, and then use the mouse to click and hold on the tip of the TMS peak. The position of this peak in ppm is given at the bottom right of the screen. Switch tabs to the NMR program and type FO, followed by a space and then this value. Again, pressing Enter will lock in this value. The program will convert this to Hertz and display the offset among the other parameters. Run the spectrum again, and then open it in Nuts. Now the TMS peak will appear at 0. In the event that the baseline is uneven, you will need to adjust the phase of some of the peaks. To correct only one peak at a time, we use the key combination PE. First, double-click again to activate the zoom function. Then, highlight the peak in question and press 1. Then, highlight another peak that is in phase and press 2. The TMS peak works well for this function. Then press Enter again to exit the zoom function, followed by the P and E. Then, click and hold the left mouse key, which will allow the peak set as 1 to be adjusted. Move the cursor back and forth until the baseline sits relatively flat. Once this is satisfactory, click and hold the right mouse key and adjust peak 2. Be sure to check both peaks again by clicking the left and right mouse keys once more, and once they are both in phase, press Enter to exit this function and view the corrected spectrum. Be sure to save the spectrum with a suitable name and print it off if required.